I didn't know. We've already. Come on, guys. What's the name? Capital. I wish people that. Middle name. I wish people that. Next round. She's so.
Hey guys, have a seat, please.
And we're back.
Welcome back.
Okay, so guys, these are other inequality problems that kind of just get thrown into the same section. So they kind of seem like they're kind of out of place, but they're still inequalities, so they make sense. And really, if we do one of each kind, I think you guys will recall how to do this. So these are called compound inequalities. You learned these in Algebra 1, but you probably didn't see them again after that. So compound inequalities are basically where there's more than one inequality in the same problem. So these don't have absolute values, so you don't have to worry about the two equations. So you don't have to set up a positive and negative version of this. These are just compound inequalities. So if you look, so these are two separate problems here. So this first one asks us to solve this, but if you look, there's two separate inequalities in the same column. Anyone have an idea or know what they're supposed to do to solve this? Do you remember this at all? Yeah, Ethan? Yeah, you're trying to get that x alone in the center. So this is called like an and compound inequality, and A and D, in muffled voice. So this is an and compound inequality. And what Ethan suggested is that we get the x alone in the center. So we're going to get x alone right here. So we're going to isolate x. And whatever I do to the center, I have to do to each side. So I'm kind of solving like two equations like simultaneously here. So there's different sides of the equals or the inequalities here. So what'd you say?
Railroad track.
Railroad tracks, yes. What do you want to solve? What do you want to do to solve first?
Subtract 4.
Yeah, so let's subtract 4. So if I subtract 4 here, I have to subtract 4 from either side as well. So from here, and also here as well. Yeah, and a lot of you guys, I taught you this, so at some point you did learn it. Yeah.
It's -9.
Yep, over here.
Okay, good job.
Well,
No, that was her showing what we're doing.
oh yeah, I was trying to show my steps.
Yes. Whoops.
Now, when I subtract, do I have to worry about flipping inequalities?
No.
No. So the inequality stays as it is right now. In the middle, I have a negative 2x, and then an inequality minus 6. Or sorry, less than 6, sorry. Now again, like Ethan mentioned, we want to get that x alone in the center. So what's our next step? What kind of 2 though?
Negative.
So we're dividing by this negative 2 here. Since I'm dividing by negative 2 in the center, I have to divide by negative 2 on either side. But what do I also have to remember when I divide by negative? Flip the inequality. So this one has a lot going on. So I chose this one intentionally, probably tougher than most of the ones we'll see in our homework, but I have to remember to flip that inequality. So I'm gonna write myself a little note over here, because I have to flip the inequality because I divided by a negative. So this one flips, and this one flips. 6 divided by negative 2 is a negative 3. Negative 9 divided by negative 2 is positive 9/2 or positive 4.5. Now, if I wanted to graph this, hopefully you guys can read this as, I kind of read it like a little bit backwards. I start at the smaller number. Negative 3 is less than x. That means x is greater than negative 3. But x is less than 4.5. So it'd be in between negative 3 and 4.5. Blow a circle, open. X is greater than negative 3. It's trying to eat the x, so bigger than negative 3, but it's smaller than 4.5. So this would be an and inequality. And if you guys are ever like, I remember this kind of, but not a ton, like not that I don't want to help you. I'm glad to go through more examples with you. But if you're ever stuck, you can always, like, the book has another, I don't do the examples the book does because of the fact that I want you to have more examples. The book does more examples and, just know that, that there's other places to find more examples, or you can ask me, you can say, like, can you do another one like that? And I can sit with you and do a whiteboard, or if the whole class doesn't need it. So let me know, you guys. And then finally, our OR inequality here. Now, an OR inequality is kind of the easiest kind. You just solve them each separately and put an OR together at the end. So I'm going to solve one half, solve the other half, and say it's one or the other. So I'm looking at just this part right now. So what am I doing first? Subtract 2 from each side. And then divide by 2. So A is less than 3. And I would say 4. Next one. Add 3. Divide by 3. A is greater than or equal to 4. What's that? That's the equal to line. Sorry, my equal to line got a little crazy there. Remember, we have the equal to line. Mine's always crooked. Sorry, it should be flat. Okay, as long as you can tell. I guess flat wouldn't matter for negative or positive. So open circle, closed circle. A compared to 3 is less than 3. A compared to 4, it's greater. So 4, one or the other. It's not both. It's not in between the two. Bless you. Okay. So like I said, I'm altering homework slightly. I'm probably making it shorter overall, but I'm taking out some problems that we didn't do examples of. So I think that probably helps it a little bit. So I'm probably just suggest rewriting what it says here. So 52 to 53, same pages, or starting a little bit earlier. We're going to do, and it does ask you to graph, I think, almost all of these, so please do get in the habit of graphing them. 9 through 13, add. And then starting again, we're skipping a bunch, then 27 through 43 add. And then we're adding number 40, that's an even. So that's why it's not in that range of values. So altering the homework slightly. It's asking you guys to graph them, so please graph them. She's moving you.
I don't want to hit my head.
All right, have a good day. Yes.
See you tomorrow.
Look like it looks